Hello everyone, I'm Zhang and a Lantern Community Ambassador. Today, I'm very excited to bring you a brand new series of courses about how to use and build with OceanBase. In this video, which is the first episode of the series, we'll start by introducing some of the core concepts of the V1 version of the agent. This will serve as the theoretical foundation for our upcoming videos. This course is jointly produced by the OceanBase and LangChain communities. You're also welcome to follow my social media to stay updated with detailed information about this course. Alright, so next, let's take a look at the main topics we'll be covering in today's session. There are three main points. First, we'll walk you through how to create an agent, with the core being the create agent function in this version. Next, we'll show you how to create simple tools and integrate them into our agent. Finally, we'll demonstrate how to run the agent using the invoke and stream functions, with a special focus on the stream function. It provides the capability for streaming output. Alright, let's start from the very basics, how to create an agent. Before we get into how to create one, it's important to clarify what an agent actually is. In LangChain version 1, an agent specifically refers to a reason act, or React agent. It consists of the following three main core concepts and components. First is the language model, which is undoubtedly the brain of the agent. It's responsible for reasoning, understanding, and interpreting the user's questions, and planning the core processes within the agent. Then, tools serve as its main executors. They are responsible for carrying out specific operations and sending the results back to the language model. This allows the language model to think, especially to reflect. Tools also act as connectors to the external world, enabling the agent to retrieve data and systems from outside and integrate them smoothly. In particular, most retrievers that fetch data within the system are implemented through tools. The last and very important key point is that the agent operates as an execution loop. It emphasizes the concept of a loop, and at the same time, this loop must be stoppable. There are clear stopping conditions so that after the language model has done enough reasoning, it can terminate the loop and produce the final result. So right now, we actually have a new way of describing this. How do we define an agent based on a large language model? It's essentially a software entity that achieves a goal by executing tools in a loop. You can check out this link to learn more about how this article explains and defines the concept. This is currently a pretty popular way of describing it. Alright, moving on, we can see that for a reason act React agent, there's a very clear loop structure. Within this loop, setting aside the input and output, its core consists of two main components. One is the model, and the other is the tool. The model is undoubtedly the core here. It's responsible for understanding the user's input, planning actions, and after receiving the results from the tool's execution, it needs to reflect and reason further. Should we proceed with further actions, or once we've obtained the result we need, can we just output it to the user? This is the core idea behind the reason act model, or algorithm, which we can better understand through the following. We can refer to the official paper for further details. Alright, next let's take a look at the core components of the entire React agent. First is the model. You can use the link above to learn more about the detailed definitions of models in the LangChain V version. Here, we're mainly going to introduce two ways to use models in the create agent process. First, we have a static approach, which itself is divided into two types. The first type is that we can define the use of a model by specifying the model's name. Behind this, it actually uses the methods from the LangChain code, like the init chat model method, so there are some specific ways to write it here. You can refer to the model's documentation page to learn more about it. The second way is that we can directly instantiate the model. For example, if you're using an OpenAI model, you can instantiate it with the corresponding chat OpenAI class. After instantiating it, you can then pass it into create agent, and that works as well. We call these two methods static model definitions, meaning the model is defined when you create the agent. In contrast, there is also a dynamic way to create and instantiate models. The main approach we see here is to use middleware, which we'll focus on in later sections. We'll use a function from the middleware called wrapModelCore to implement this. Here, we use a decorator to define a function that handles the model call. Inside this function, we can access a request object. This request is a model request, which contains the details of the model call we're about to execute. It contains a lot of information, including status information that you can see here, as well as some contextual information. Most importantly, within this function, you can override the information in this request. For example, here we have redefined it. This model needs to be bound to an actual instance of the model. For more complex situations in model selections, especially for tasks like intent recognition, simple problems can be handled by simple models, while more complex problems require more advanced models. In these scenarios, using this method of dynamically setting the model is extremely useful. So to sum up here, for simple situations, using a static model directly is more than enough. But if you're dealing with complex cases that require complicated routing or optimization, you can consider using middleware to dynamically load models as needed. Alright, next up is tools. We'll have a detailed introduction on the following pages about how to define and handle various operations within the tool section. For now, we'll skip this part. The next core component is the system prompt. There's no doubt that for large models, the system prompt is extremely important. There are also two ways to define it. First is the static definition method, where we can pass in and write the system prompt parameter when creating the reg agent. For more complex scenarios, it's similar. In the middleware, we have a dedicated function called dynamic prompt. We can also use its decorator style to bind a handler, that is, to bind a processing function. Here, what we're showing is how we combine variables from the context of the model's request. We retrieve the user's role, and then set different prompts based on that role. This is a typical role-playing scenario. By dynamically binding prompts in this way, we can very conveniently exercise a certain level of system-level control over the behavior of a React agent. So we can accomplish this through dynamic prompts. But in most cases, using static system prompts is actually enough to cover many scenarios. Next, we have memory. Here, what we mean by memory is short-term memory. You can also use this link to learn more details about it. The core of short-term memory is that it doesn't persist across conversations. It is only valid within the current conversation. Once you switch to a new conversation, this part of the content is lost. For example, in the LangChain OceanBase version of Create Agent, it automatically includes a state. In this kind of short-term memory, the state is the message history, a record of the conversation's message history, so you don't need to worry about it. You don't need to worry about how to manage this message history. All the operations are encapsulated for you within Create Agent, so you can just use it directly. This is one way to do it. The second way is that you can also extend the structure of this state to some extent. For example, as we can see here, we can use the state steamer method to introduce some custom fields. You can put them into this state, and in this way, you can perform further operations within the tool. What we use more commonly is to combine it with middleware, which we will introduce in later videos. That's not the focus of this video. For now, just remember that we have an automatically created and maintained message history, and there are ways for you to customize the state as well. That's all you need to do. If you want to learn more about long-term memory, meaning memory that persists across sessions and conversations, you can check out the link below for more detailed information. Next, let's take a look at how to use tool invocation. Using tool invocation in the LangChain version is relatively simple. First, we can see that we introduce a trail function from NetSpace, and this function can be used as a decorator. Then, you use it to decorate your specific tool functions, like the search and weather function shown here. After decorating these functions, you can pass them into the tools parameter of Create Agent. You just need to put them into a list in this parameter, and after passing them in, they become a toolkit. This way, you can use them later on. Once you've passed them in, the implementation is actually very simple, but you gain some built-in capability enhancements. Also, by default, we can perform parallel tool calls. Of course, this depends on the capabilities of our model. If the model supports parallel tool calls, then within this Create Agent framework, you can naturally take advantage of parallel tool invocation. And then you can use middleware to dynamically select tools. At the same time, thanks to the Land Graph Foundation, we have some automated tools, execution logic for various tasks, and robust support for state persistence. All of these are pre-built capabilities that combine the entire LangChain and LangGraph ecosystem. As for exceptions, if a tool encounters an error during execution, we also have ways to handle it. In this case, the solution provided in version 1 of LangChain is to let you use middleware to handle related operations yourself, and the process is quite convenient. As you can see here, we can import a tool function like wrap to call, then use it as a decorator to define your own exception handling logic. Here, we're doing the simplest form of exception handling, which is just catching the exception first, and then after catching the exception, we reformat it and output it as a tool message. Note that for handling something like to call, which is a type of tool invocation, we need to return an appropriate message in the loaded version. We need to return a proper tool message. Only then can we ensure that the entire message history is valid. Otherwise, it will throw an error. So using middleware is actually very convenient. All we need to do is prepare a series of middleware and then pass them into create agent, and we can use middleware to control these tools and handle such exceptions. After everything is executed, the final result will be a tool message that we have already customized. Alright, so in real-world scenarios, we can see that there are actually a lot of use cases for React agents. In these situations, we often rely heavily on the support of various tools. For example, the most common one is the search tool, which we use to find information from the web and online sources. As for data, we also have retriever tools. These types of tools are also used to obtain data, but they are more focused on accessing internal or private information within an enterprise or company, typically by using vector storage or hybrid search methods to retrieve information from internal sources. At the same time, we also have toolsets like file system tools, which allow us to operate on content stored on our local host machines and access data from local devices. Finally, there are some tools that have become quite important recently: multimodal tools. They can better integrate all types of data we have now: text, audio, video, and data from all fields, bringing them together for a comprehensive production. This is currently a tool with a lot of potential. Of course, regardless of all this, actually. In our current system, under the agent framework, making good use of tools, categorizing them properly, and choosing the right tools are all very important prerequisites for improving our system's capabilities. There are some best-known methods, some best practices for using tools well. For example, you need to clearly define the tool's description and the scope of its capabilities. Explain this thoroughly so that the large model can better understand what it can do and how to use it. At the same time, we need to handle tool exceptions and implement retry logic properly. In Bluebird V, we can conveniently manage this through middleware. Finally, we can also combine these tools for use, including both serial and parallel combinations. This approach helps us handle more complex scenarios more efficiently. For example, in Deep Agent, a lot of parallel tool operations are used to improve execution performance and execution capability. Alright, so finally, let's take a look at how to execute our agent. Here, the main methods are invoke and stream invoke, which are the most common ways to call it. The usage is simple, just use agent.invoke. So what are its features? Well, its input is simply a list of messages. In this message list, you can have a single entry, like just a user's message, or you can include a system message, a user message, and an AI message together as a complete set of messages to be passed in as data. The key characteristic of invoke is that it must complete the entire process before returning the final result to you. Here, we can also see that after you finish one execution, for the next execution, you just need to combine your previous messages and then pass them to invoke for execution. It ensures that all the information you provide is fully processed before returning the result to you. Compared to invoke, if we need to see the returned information in real time, especially since nowadays we basically all use streaming output to get that typewriter effect, we need to use the streaming interface. You can check out the link above to learn more about the detailed definitions and usage of streaming in the Blue Chip V version. Just to briefly mention here, besides being able to display the agent's execution process, we can also provide output by token, that is, outputting the token source one by one. For outputting by token, in LangChain and LangGraph, we support custom content updates. At the same time, we offer different streaming output modes, and these output modes can be combined and used together, allowing you to output content using several modes simultaneously. Here, we'll show you the two most commonly used output modes. The first one is called updates. Its core idea is that content is only output when there is a content or state update during the execution of a node. What it outputs is the entire updated content of the node. This is the first and most common method. The second one is called message, which is mainly responsible for streaming output by token. These two output methods can be used at the same time. You can pass them into stream mode as an array, and after doing so, you'll be able to get both types of streaming output results simultaneously. Then you can further process them as needed. So as a core capability of the LangGraph and LangChain ecosystem, streaming output is actually quite powerful and comprehensive. You can learn more about it in detail on the streaming page. Alright, finally, let me introduce a few core advanced features. We won't go into detail about these features in this video. I'll just mention them briefly, because we'll give you a detailed introduction when we actually use them in later videos. First is middleware. For now, you can simply think of middleware as something in the entire React workflow in the loop process we saw earlier. There are a lot of customizable nodes built into it. You can attach different handler functions to these nodes to perform your own custom processing. For example, as shown here, the before model or after model hooks are easy to understand. We have them both before and after executing the model. There are corresponding hooks, and you can attach your own custom handler functions to them to perform related processing. At the same time, we can also perform corresponding operations at two key nodes, model execution and tool execution, each with its own related handling methods. Simply put, this mechanism is the core of the entire version. It allows everyone to seamlessly carry out certain tasks. Business logic injection. This will be explained to everyone in more detail in the upcoming hands-on videos. The second point is structured output. If you're using a React agent and you don't want it to just output plain text, you can also require it to output a structured format. You can learn more about the specific details through this page. As for structured output, we provide different modes for defining structures. One is automated. You just pass in a simple structure. The other two are specified modes, which are ways to specify the processing logic and handling strategy. The most essential and commonly used is the tool strategy, which forces our model to use tool invocation to output structured data. The second is called the provider strategy, which outputs based on the built-in capabilities of your model provider, such as OpenAI. AI and Grok, for example, have their own native APIs for structured output, and they use these APIs to generate output. Structured output and handling have been greatly enhanced in the V1 version of LangChain, including improved exception handling. The final result will be placed in a dedicated field called structured within the result. This is returned to the user in the response. Alright, so that's pretty much the core content of this video. Let's do a quick summary. First, what is an agent? The simplest way to understand it right now is that it's a loop involving a model and tools, using a loop to let a large language model call tools, and ultimately get the result you want. So how do we go about building our agent? First, I recommend that everyone start by using the simplest approach, statically calling model tools and configuring them in a static way. Once you're comfortable with the static method, you can use middleware to handle various complex and effective dynamic processes. Third, the agent we're currently using is convenient and powerful mainly because it's built on top of LangGraph, which is basically the most advanced agent development framework in the industry right now. It offers a whole range of agent-oriented user experiences and robust support for user experience capabilities, including things like streaming output, persistence, exception handling, and human-computer interaction, all of which are managed by it. It serves as the foundational runtime support for the agent, which is why the LangChain V1 version of the agent that we built on top of it can deliver such powerful and stable performance. Finally, what we need to mention is that the most core mechanism of the agent in this version is the middleware. It provides us with a lot of hooks throughout the entire React process, allowing everyone to easily inject their own business logic, and to extend and customize the entire loop with production-level capabilities. So when we move into the V1 phase of the crowd and start using LangChain and the VE agent for development, we actually see an improvement in our development efficiency as well. Using the native language is indeed very powerful, but the learning curve is relatively steep. So compared to the LangChain version of the agent, we actually recommend that everyone start with LangChain first. When you hit the limits of its capabilities, then you can fall back to the native language. They can connect seamlessly because their underlying framework and runtime are the same. The LangChain V1 version of the agent can also serve as a node. In the LangChain version, within the agent construction framework, it can act as a node or as part of a node to execute tasks, so they can be seamlessly integrated. Finally, if you want to start learning our course, we recommend that you first install LangChain and the agent. Here, we suggest you use UV as your package manager to set up your project. For example, on the left side, you can see a basic project configuration file. At the same time, we highly recommend that you manage your code quality. Here, we suggest two tools. One is the Python tool Rough, which can help you assess code quality and automatically perform some tasks. At the same time, we recommend that you use a makefile to further manage some of our core commands. The use of these tools will be covered in our upcoming practical projects, and our project templates will provide them for you. You're also welcome to get some preliminary understanding of them in advance. Alright, that's the main content of this video. You're also welcome to scan the QR code on the right to learn more about the official LangChain website and some of its core product offerings. We also invite you to keep following this course series. In the next session, we'll introduce how to build a basic system workflow. Thank you, everyone.